Hello, Gabriel. I hope you are doing well. Actually, I saw your message. Hi, one more time. Okay. Is everything okay, Gabriel? Did you start your new academic year, school year? Yes. When did you start? Is September or August? I see. So are you having online class or in campus? Online. I see. I see. What can we do? Gabriel, how old are you? Are you 13 or 14? Oh, 12. Oh, I see. Good. So you are grade 7, right? The secondary one. Good. Gabriel, let's continue. As you know, actually, we started another topic that is number and algebra, or numbers and the algebra. Okay. So that's a kind of, what is it, transition from primary school to secondary school, because algebra is not taught in primary school. When you go to secondary school, after doing some revision, algebra is offered to students or taught to students. Simply algebra. What is algebra? Algebra is a tool, right? It's a kind of tool that we use letters, or we call them variables in math, to solve the problems. So that if you're given any problem, by modeling this, we can convert this into algebraic equations. Now the problem is solving algebraic equations. Before we start this, we have to actually practice some important or fundamental concepts. Those are, what are the numbers? That is classification of numbers, right? Starting from counting numbers, that means natural numbers, and after that, what is it? Whole numbers, then integers, then rational numbers. Then we also include irrational numbers, and together we consider problems in real number system. But with you now, we are just talking about one actual system, that is operations on, what is it, rational numbers. So last time we talked about rational numbers and its operations, right? Simply, rational number is the ratio of two integers, where of course denominator should be different from 0, because we cannot divide any number by 0. That is the exception. So if you can just write any real number as a ratio of two integers, we call them rational number. Okay, and some numbers cannot be written. Actually, when I say some numbers, it's not some. Actually, we have also infinitely many irrational numbers. Numbers which are which cannot be written as a ratio of two integers, they are called irrational numbers. Examples for irrational numbers, as I told you, square root of 2, square root of 5, square root of 7, and also very famous number, that is pi, for example, right? If you just take any circle, divide its circumference by its diameter, it's always a constant number. That's called pi. That's also a rational number. We have some numbers. Golden ratio, for example, is also, what is it, a rational number. Today, we are going to talk about number line and comparing magnitudes. This number line is really important to compare two numbers, okay? Because if we actually, in two different ways, we can compare numbers, right? One is algebraically, another one is geometrically. Geometrically means that if you just draw a number line, if you're given any real line, you can actually mark a point that represents that number in the number line. Okay, because every number has a unique location in the number line. And after that, the numbers to the right is greater than the numbers to the left. This is how we compare. If two numbers overlap a single point. That means that they are equal. Anyway, today with you, we will talk about what is this number line and comparing magnitudes or comparing two different numbers. Okay, what is a number line? Simply, after we study about the number line, and also we have geometric representation, because geometry and mathematics, we don't say mathematics, let's say algebra. There's a kind of interplay between these two branches of math, because algebra and geometry, they are two different branches of math, right? And sometimes to visualize something that is a concept in algebra, geometry helps us. Sometimes to solve problems in geometry, algebra helps us. This is a kind of interplay between algebra and geometry. So now let me just draw one straight line, okay? So now let me just plot one point here. It is, let's say it is 0 here. Actually, to the left, I can continue. It is -1, -2, -3, right? So after that, actually, we can just mark our numbers. Here we have 0, 1, 2, 3, 4, 5, okay? And actually, between every two numbers, we just call this a unit length. So a number line is a straight line indicating the 0. And here we have a 0, the origin, the direction of positive number, and the unit length. And usually we don't actually show this. Sometimes we should show this. It doesn't change anything. So to the right, that means that if you just walk to the right, the number is increasing. If you walk to the left, right, in the opposite direction, that means that the numbers are decreasing. And to the left of 0, we know that we have, negative numbers. So here we have is a kind of borderline or border point. Let's say it is 0. 0 is a neutral number. That means that it's not negative, it is not positive. If you just walk a little bit to the right, actually we just enter the region of positive numbers. So here we have 1, here we have 2, and here we have 3 continuous. If you just walk a little bit to the left of 0, right, here we have -1, and here we have -2, and here we have -3, and blah, blah, blah. Actually, why did we introduce this? Because also these are really important to, to record a lot of things. For example, let's say the lowest temperature is 0. At 0, right, if you're talking about the temperature, let me just draw vertical line, and this is our 0. It's a very important point, because at this degree, the water freezes, right? But actually, do we have temperature below 0? Yes. Now, how do we indicate these actual temperatures, right? At the time, we need to use negative numbers. Like, so here we have above 0, here we have 1 degree, it is 2 degrees Celsius or 3 degrees Celsius. But below 0, below the freezing point, right, we call this negative numbers, -1 and -2, -3. And also for sea level, right? For example, as a sea level, above the sea level, the height of something is measured in positive numbers. And how about the below the sea level? We use negative numbers so that we can actually see we should see the difference. At a certain point, actually, that means that we're just going below the certain point. That's why actually negative numbers are really important. Okay, so let's see this example. Referring to the figure given below, find the value of a plus b plus c times d over e. Solution. So this figure is given, that is a number line, right? So as you see here, the numbers to the right is greater than the numbers to the left of it. So now here, as you see, already these numbers are given. So here we need to find the value of this a plus b plus c times d over e equals, what is a? Here, a is just sitting over this -6. So the value of a is -6. Plus, how about b? It is sitting just over, right, this -4. So its value is -4. Plus, now we have fractional line. C, it is -1 times d, it is 3. And how about e? E is equal to 7, right? And after that, just we need to simplify this. Plus times minus, that is positive, negative, it is negative. -6 plus -4, that is -10. Plus -1 times 3, -3, -3 over 7, it is -3 over 7. So now we are adding -10 to -3 over 10, because here we have, I can just write it as minus 10 plus 3 over 7. As a mixed number, actually, I can just leave it like this, right? 10, and here we have 3 over 7. So the answer is negative 10 and 3 over 7 in a mixed form. The 10 is the whole part and 3 over 7 is the fraction part of this addition. Okay, Gabriel, is everything clear? Good, very good. Let's continue. Another example, referring the figure given below, which of the following is number one, the largest, and the second one is the smallest. First, we have to find the largest and the smallest, right? So what is given here? Actually, here it is given these things. Actually, I think I forgot to put numbers. I think we just put them quickly. Okay, here we have C minus B and negative A minus B minus 1 over A. Okay. So we have to compare these expressions, right? We have C minus B, negative A minus B minus 1 over A. Here we have negative 1, A is here, and B is here, C is here, and 1 is here. Okay, now we don't know the exact value of these variables, right? But we know actually their range. So see here, A is between negative 1 and A, B is between negative 0 and C, or 1, let's say C is between 0 and 1, but greater than B, because C is to the right of B. So now let's just calculate one by one. Since see here, from the first one, let's find C minus B. What is C minus B? As see here, C minus B is this distance, right? It is, of course, less than 1, but we know that it is greater than 0. Why? Because C minus B is to the right. It is greater than 0. And also, we know that the C minus 1, right? It is less than the distance between 0 and 1, because these two things are between 0 and 1. So that is less than 1. That's what can I draw, actually, this information from their locations here. And the second one is minus A. See here, A is here, right? Minus A is somewhere to the right. So that means A is negative. So negative is multiplied by negative. So that means that this negative A is positive. And of course, it is between, right? It is between negative 1 and A, 0. And also negative A is between 0 and 1, because they must be symmetric. So I can just write here and also this negative A is less than 1. That means that actually I can just write a single expression for this. So that is greater than 0 and less than 1. Okay, and also so this C minus B is, what is it? C minus B greater than 0 and less than 1. And how about A minus B? So this A, negative number, right, minus B. So actually this A minus B, so from here this A minus B, what is it? It is less than 0, because negative number and subtracting positive number from negative number. And to understand this immediately, you can just say one example. For example, here we have 0. Let's say here we have negative 1 over 2. And here we have, for example, 1 over 2. Okay, what is 1 minus 1 over 2? Minus 1 over 2. That's equal to negative 1, which is less than 0. And that's why here A minus B is less than 0. It is greater than or less than 1. We don't know, because not enough information here. Okay, but what I know here is actually their sign is 0. And how about negative 1 over A? Is here 1 over A, right? It is actually A is negative number. So if you multiply minus, right, this negative A by, A by negative 1, it will be positive. And you are dividing a number which is less than 1, dividing 1 by a number which is less than 1. So it is greater than 1. So here then, minus 1 over A, I know it is positive. More than that, it is greater than 1. Okay. Example, for example, again, if, just example to understand this, a equals negative, for example, let's say 1/3. Now from here, what is minus a? Minus a is, it is 1/3. And how about 1/, actually it is minus, right? Here we have minus 1/a, that's equal to minus 1/-1/3, which is equal to 3, right? Because you're just dividing 1 by 1/3. The result is 3. That's greater than 3. In general, if you divide 1 by any number that's between 0 and 1, the result is greater than 1. So now we can just see that, let's see here, this c minus b between 0 and 1, we don't know their exact value, and negative a between 0 and 1, but here, two things, right? This a minus b is less than 0, and minus 1/b, that is greater than 1. So now from here, then we can just draw a conclusion. This one is, what is it? The smallest. And this one is the greatest. Because we are sure that minus 1/a is greater than c minus b, greater than minus a. So dot, 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 this a minus b is the smallest. And what is it? Minus 1/a is the greatest. Okay. Another example, the points representing integers on a number line are called integral points. Later, actually, in plane, we call them lattice points, but here, call them integral points. The unit length of a number line is 1 centimeter or 1 centimeter. Draw a line segment of 2008.5 centimeters over it. How many integral points could be overlapped by the line segment? Okay, actually directly you can solve this, but sometimes if you actually don't understand, if you cannot visualize, because this 2008 is quite long, right? So we should just think of one analogous problem. That means similar problem, but the simpler one. And instead of this 2008, for example, if we just talk about, let's say 8.5, right? So we are talking about this 8.5 length. Okay, this length, it is 8.5 centimeters. So if I just put this on the number line, how many integral points could be overlapped by the number line segment? It depends on how you put this, right? Maybe starting from 0, I can put like this. Actually, one end is overlapping the starting point is 0. Okay, so here I can just draw the number line here. So this one is 0. At the time, this point will be 8. This point will be 8 and continue, right? So another way is I can actually just shift this a little bit. Okay, the starting point is not overlapping the starting point. So also I can just put this like this. Maybe 0 is here, right? Something like this. Okay, so 0 is here, maybe 1 is here. At the time, this 8.5, right? 8.5 will be, it is somewhere here. Okay. In either case, for example, how many points will we have? So if it is in the first case, starting from 0, and here we have 1, 2, 3, 4, 5, 6, 7, 8, right? That is 1, 2, 3, 4, 5, 6, 7. How many points? We are starting from 0. That's why here we have 9 integral points. Okay. In the second one, actually the first one is starting from 1, right? It is 1 and 2 and 3, and here we have 4, and here we have 5 and 6, and maybe the 7. Here we have 8. But actually, we're just taking these points here now. Only these points. How many points here? We have 8 points. 8 integral points. Just write like this: integral points. Okay. So in a similar way then, actually this 2008, right, the points representing on a number line, right, here, if you just overlap the starting point of this line segment over 0, you can just extend this, right? So the answer will be either we will have 2008 or 2009 integral points. Because it's 2008.5. When it's 8.5, it is 8, right? Or 9. When it's 2008.5, that is 2008 or 2009 points. Because if the starting point overlaps over 0, right? We are starting from 0. 0, 1, 2, 3 until 2008. How many integral points? 0 is also an integer. That's also you have to include 0. 2009. But if the starting point of the line segment does not overlap 0, at the time we should start counting with 1. At the time it will be 2008. Okay, so there's either 2008 or 2009 points. Actually, the line segment overlaps, right? Overlaps how many? 2008 or 2009 integral points. Another example, if there are 2007 integers from a to negative a, find the range of possible values of a. So it says that from a to negative a, how many 2007 integers? Okay, so from here, solution. Okay, now first, actually, the first case is suppose that a is positive. Okay. If a is positive, now we are talking about this line segment. Here we have negative a, and here we have a, because a is positive, negative a to the left. If there are 2007 integers from a to negative, find the range of possible values of a. So here a is, we are not saying that a is an integer, right? So it's just any real number. It may be a rational number. So here we are saying that 2007 numbers. So now suppose that a is positive, and how about if a is, what is it? Also integer. If it is integer, here we have 0, right? And how many numbers will we have here? For example, if we just take, let's say here we have negative 1, and here we have 0, and here we have 1. Negative 1 and 1, they are integers, right? How many points? Here we have 3 points, right? How do we know that? 1 minus negative 1 plus 1, that's equal to 3. And also from here, then how many points will we have? Here we have a minus negative a plus 1. So we will have 2a plus 1 actually points here. So actually we are saying the 2007, so that's equal to 2007. Now if you just solve this for a or 2a is equal to 2007. Take 1 to the right hand side, minus 1. Which is equal to 2006. Then what is a? A equals 2006 over 2. So that's equal to 1003. So it says that find the range of possible values of a. So that's one possible value, okay, to 1003. So now if I just shift this a little bit, suppose that a is, the second case is, let's also consider this case. How about if a is negative? Okay. If a is negative, at the time we will have the same thing here. Here we have negative a, actually here we have a, and here we have negative a, right? And here we have 0. And also if it is integer, actually this a is integer number. So at the time, again, we'll have the same thing, but here we have minus a plus 1 is equal to 2007. Now from here, minus 2a is equal to 2006. So what is a? Minus 1003. Okay. So actually this 1003, right? Actually, if a is greater than 1003, right, it will be more. Actually here, even if I just add a little bit number here, for example, okay, here we have minus a plus 1. And here we have, what is it? And here we have a plus 1, okay? If you just pick any point here between here, for example, to here, right? It does not change anything because all the integer numbers are here, okay? Also for the second case, the same thing. If you just pick any number that's a bit less than a bit greater than a, the number of integer points does not change, okay? Of course, we are not taking this a plus 1 minus a plus 1 or just a plus 1. So at that time, the answer will be, what is it? Answer will be possible values of a. For the first one, right? For the first case, it is 2004 less than a less than or equal to, sorry, it's not 2004, 1004. 1004, here we have 1003. Or the second one is see here, minus 1003, right? So minus 1004 less than a less than or equal to minus 1003. So these are the possible values of a. Because here, as say, if I just add a little bit, but not -2, right? A little bit, the number of integer points does not change. So you can just take any point over here. Of course, not crossing this -2 and the all right. Let's continue. Comparing the magnitude of numbers. Okay, now here these are simple, Gabriel, but very important, fundamental, how to say, let's say properties over real numbers. So the first one is for any three numbers, right? It says that, let me just put as a point, for any three numbers A, B, and C. When you just say any three numbers, we are just mean that any, if you pick any three numbers on the number line, that means that they are real numbers. If A is greater than B, and if you just add any numbers to both sides, actually this actual comparison does not change. So that means that still A plus C will be greater than B plus C. That's very important thing in solving equations, because how do we eliminate some term or number or expression from both sides of the equation using this one if something is added? And for the second one is for any three numbers, A and B and C, if A is less than B and C is greater than 0. So again, if you multiply both sides by positive number, again, it does not change, right? So immediately this kind of questions to understand, well, you have to give some example. Like for example, some examples on the first one, okay? Let me just write example 1. Okay. Example 1. Okay, so we know that, for example, actually 4 is greater than 1. Well, let me not say 1. Let's say it is 4 is greater than -3. Now, if you add both sides by 5, for example, 4 plus 5, and here we have -3 plus 5. It's still true, right? From here, 4 plus 5 is 9. 9 is greater than -3 plus 2. Okay, because what is a geometry interpretation? Let me just explain only one thing. Geometry interpretation is A is greater than B is, means that B is to the left of A. Here we have A, sorry, here we have B, here we have B, and here we have A. You see here A is greater than B. So adding C to B and A means that you're just shifting these numbers C units to the right. That means that here we have, this one is, okay, something like this. Okay, so this one is B plus C, and this one is A plus C. I mean, these points, okay? So this unit is, what is this? C units to the right. If you just shift both numbers, C units to the right, actually, again, still, A will be to the right of B. Okay, that's a geometry interpretation of this property. The second one is, actually, if A is less than B and C is greater than 0, C, it should be greater than here. If A is greater than B and C is positive, if you multiply both sides by positive numbers, again, actually this inequality does not change. Example 2, for example, again, here let's say this 10 is greater than, let's say, -5. And if you multiply both sides by 2, for example, or 5 or 4, 4 times 10, it is 40. 4 times -5, it is -20. And 40 is still greater than -20. And for the third one, for any three numbers, A, B, and C, if A is less than B, and C is, why did I write less than? Should be greater than. If A is greater than B and C is negative number, then if you multiply both sides by negative numbers, so we have to change, right, the inequality sign. Like for example, example 3, we know that what is that? -2 is greater than -6. So now if I multiply both sides by negative number, what happens here? Let's say -2 times -3 and -6 times -3. We are multiplying both sides by -3, right? So from here, -2 times -3, it is 6. -6 times -3, it is 18. 18 is not less than 6. 18 is greater. So 6 is less than 8. And so here, this inequality sign is changing, right? And we multiply both sides by a negative number, or if you divide both sides by a negative number, also we need to change actually the inequality sign. For number 4, for any three numbers, A, B, and C, if A is greater than B and B is greater than C, then A is greater than C. So that means that for number 4, let me just write it here. Okay, here we have a number line. A is greater than B, right? And B is greater than C. That means that here we have B. A is greater than B. That means A is to the right of B. And C is less than B, or B is greater than C. That means C is to the left of B, is like this. So see here still, actually this A is to the right of C, which means that A is greater than C. How about for four numbers? For any four numbers, A, B, and C, A, B, C, and D, if A is greater than B and C is greater than D. If you just add A, greater parts, A plus C, and B plus C, so A plus C will be greater than B plus C. And if you subtract the same thing, A, greater number, minus smaller number, D, and B minus bigger number, so it will be greater. And for any four numbers, A, B, C, and D, if A and B, A is greater than B, B is positive, and C is greater than D, D is positive. So A times C is greater than, because this A and C, right? These are big numbers, multiply B and D small numbers. So A times C is greater than B times C. And also if you divide A by smaller number, B by bigger number, here's C, right? They are greater. So that means that the same thing actually, because if they're positive, A times C and B times D, right? And just actually interchanging this, take this C to the right-hand side and D to the left-hand side, you will get this expression. And how about if A is greater than B and B is greater than A? If you divide 1 by A, right? And let me just write here. So here, so since A is greater than B and it is greater than 0, so both are positive, right? So now, actually, I can just divide both sides by, what is it? A times B. A times B, because if you divide using the first property, if you just divide by positive numbers, it doesn't change anything. So now this A cancel each other. What we have here, 1 over B, and B cancel each other, greater than 1 over A. You see here, 1 over B is greater than 1 over A. This is how we obtain this. And also this A and B, and they are greater than 0, and N is a natural number. So N is a natural number, means that is equal to 1, or 2, or 3, or 4 is counting numbers. Then A to the power of N is always greater than B to the power of N. Of course, if they are not equal. Like, for example, 2 to the power of anything, for example, 3 is greater than 1 to the power of 3. Or 5 to the power of 20 is greater than, for example, 3 to the power of 20, because these bases are, 5 is greater than 3. Okay. So let's see some examples now. Example 5. So let me use blue now. Solution. Suppose A equals negative 235.5 minus 235.8. B is 235.7 minus 235.8. C equals 235.7 minus 235.8. Arrange A, B, and C in descending order. So descending order means from the greatest to the lowest, right? Or the smallest. Of course, to compare these kind of numbers, first, we have to simplify, right? We have to simplify, and after that, we can just locate them on the number line and compare these numbers. So if you just simplify the first one, A is equal to minus 235.7 minus 235.8, right? So this minus is plus, so that is minus 235.7 plus 235.8, which is equal to 235. 235 is gone, minus 0.7 plus 0.8, so that's equal to 0.1. That's the value of A. And how about B? For B, 235.7, that minus 235.8. So 35, right, is 230, is gone. 0.7 minus 0.8, that is minus 0.1. And how about C? C equals 235.7 minus 235.8. So minus is plus, right? Here we have, what is it? Plus 235.7 plus 235.8, which is equal to 235 plus 235, that is 470, 0.7, 0.8, 1.5, so that is 471.5. Okay, let me just check to make sure there's same. Okay, I think it's wrong. So arrange A, B, and C in descending order. So 471.5, it's the greatest, right? And second one is A, and third one is B. So dot, dot, dot. Our answer will be, what is it? C is the greatest. And the second one is A, and third one is, what is it? It is B. And also I can just write as C and A and B. I don't know how. Sorry, it is C is the greatest, right? C is the greatest. C is greater than A is greater than B, or C and A and B, descending order. Another example, arrange minus 2007 over 2008, minus 7 over 8, minus 2008 over 2009, and minus 8 over 9 in ascending order. Ascending order means from the smallest to the biggest, right? So all of them are, what is it? Negative numbers. So negative numbers means that whose absolute value, okay, is greatest. Absolute value means that here solution. Okay. So absolute value, for example, A, we know that is equal to A if A is greater than or equal to 0. That's equal to minus A if A is positive. Okay, so that means that from here, like -3, absolute value of -3, that's equal to 3. Absolute value of -5, that's equal to 5. Absolute value of 4, that's equal to 4. Absolute value of 0, that's equal to 0. Okay. First, let me just compare their absolute values, okay? And after that, I can just write them in ascending order from the smallest to the biggest. So now if I just write them without their sign, okay, not to get confused, So let me just compare these numbers. 2007 over 2008. And here we have 7 over 8. And here we have 2008 over 2009. And here we have 8 over 9. First, to compare two numbers, we know that actually we have to either they need to have the same denominator or we need to cross multiply. But the first one is if I just bring them into the same denominator, 2007 over 2008. Multiply the second fraction, numerator and denominator by what is it, 251. Because 251, right, let me just write here, 7 times 251 and 8 times 251. What is it? Actually, that's equal to 8 times 251. That's equal to 2008. So that's equal to 2008. How about 7 times 251? That is 7. 7 times 5, 35. We have 3, 14. It is 17. Okay. So now I can just multiply both sides by 251. That's equal to 1757 over 2008. The next one is 2008 over 2009. And also here, I can multiply this 9 by 2009. So, okay. It's not divisible by 9, so what can we do here? Okay, I'll just keep it like this. Okay, so now 8 over 9, because if I multiply 2009, it's going to be so big. So I'm just going to do something else. So now if I just compare these two numbers, right, as you here, 2007 is greater than 1078. So I can just put this here. Okay, it's greater than this, right? So now how can I compare this 2008, 2009 and 8 over 9? Okay, to compare these numbers, I can just write this method. Okay, here, this 2008, I can just write it as 1 minus 1 over 2009. And how about 8 over 9? 1 minus 1 over 9. Now see here, if you simplify this, 1 minus 1 over 9, that's equal to 8 over 9. 1 minus 1 over 2009, that's equal to 2008 over 2009. So here we have 1, 1, right? The same thing. Actually, just I need to compare these things. Which one is smaller? So this will be bigger. See here from 1, I'm just removing 1 over 2009. And this one is 2009. This one is 1 over 9. And of course, here, these two numbers, right? Actually, this one is greater because you're removing a very small number because 1 over 9 is much, much bigger than 1 over 2009. Okay. So I can just, I think this method, I can just write this in this way and compare this much faster, I think. Okay, so 2007, let me just write it as 1 minus 1 over 2008. And this one is 1 minus 1 over 8. This one is 1 minus 1 over 2009. 8 over 9 is 1 minus 1 over 9. Okay. So see here, the smallest one, right? Actually, that's the biggest. This is a small, biggest. Actually, this fraction is actually the smallest because the denominator is the biggest. After that, actually, it is this one, right? 2008, and this one is 9, and this one is 8, right? So now that I can just write here 2008 over 2009, right? So that is the biggest. Second one is 2007 over 2008, greater than. And here we have 8 over 9, greater than, and that is 7 over 8. Right? So now I'm going to use this property. We know that if A is positive and greater than B, and C is less than 0. If you multiply both sides by C, A times C is less than B times C. When C is positive, negative, right? So now if I just multiply all of these numbers by -1, what happens here? Also, we need to change inequality sign. So it will be here in ascending order. It will be, what is it? I just need to write minus 2008 over 2009 less than minus 2007 over 2008 less than minus 8 over 9 less than minus 7 over 8, right? So now our final answer will be then, I don't have much space, so I'll just write here. Okay, our answer is here. We need to write in ascending order from the smallest to the biggest, right? Actually, we have already written this from the biggest to the smallest. Ascending order. Minus 2008 over 2009, that's the smallest one. Minus 2007 over 2008, the second smallest. Minus 8 over 9, and minus 7 over 8. Okay, and we don't have to open a new place here. Gabriel, is everything clear? You understand everything? Good. Okay, then let's see another example. It says that given this 1 over a minus 2006 equals 1 over b plus 2007 equals 1 over c minus 2008 equals 1 over d plus 2009. Arrange A, B, C, and D in descending order. Okay, now from here, at the first glance, right, as you see here, all numerators are equal. For these fractions to be equal to each other, and also now their denominators must be the same, otherwise they cannot be equal. That means that actually that the given expression is equivalent to this: a minus 2006 equals b plus 2007 equals c minus 2008 equals d plus 2009. Okay. So now, if I just actually here we have minus 2006, right? I'm just going to add all of this size 2006. Let me just add 2006 to all of these expressions, because again, I'm just using this rule. If A is greater than B, then A plus C is greater than B plus C. At the same time, if A equals B, then A plus C equals B plus C. So now if you just add 2006 to all sides, here we have A, because negative 2006 plus 2006 is 0. And here we have plus 2006 plus 2007, that is 4013. And 2006 plus negative 2008, that is C minus 2. And here we have D plus 2006 plus 2009, that is 4015. Okay. So now from here, we can compare these numbers, right? Actually, what is A? A, actually, if you just add 4013 to B, then it's equal to A, right? And actually, if you subtract C, 2 from C, then it's equal to A, right? And if you add 4015 to A, to D, then it is A. Now from here, what can we see here? Since actually we are subtracting 2 from C, that is equal to A, C is the greatest. And after that, from here, right, the second one is A. And after that, as see here, D, B minus D is positive. So B is greater here. B is second, and third one, and the last one is D. Right. Because we know that A is greater than B, A is greater than D. And also from here, C is greater than A. That means that C is the greatest of all. So I just compared this. If you want to compare B and D, write them together like B plus 4013 and D plus 4015. Subtract 4013 from all sides. So this B is equal to D plus 2. Which means that actually if you add 2 to D, then it is B, right? Which means that B is greater than D. So that is the the final answer of this question. In descending order, right? So C is the greatest, A is the second, and B is the third, and D is the fourth. So from the greatest to the smallest. All right. Another example, given that A, B, C, and D are four distinct positive numbers. So distinct means different. None of them are equal to each other. And positive numbers may mean that they are real numbers, any numbers on the number line, where A is the largest and D is the smallest. It says that A is the largest, A is the largest, and D is the smallest. And B and C, we don't know. Okay, actually, mathematically, also we can just write like this. A is the largest, A is greater than B and C. I don't know which one is greater, and also they are greater than D. And B and C are between them. So that means that, what is it, on the number line, we have two cases here, right? It's like this, A is, D is here, and the A is here, maybe B is here, and C is here. Or the second case is, here we have D, and here we have A. It is A, and here we have C, and here we have B. Either of this one, okay, we don't know, right? So moreover, it says that A over B equals C over D. Moreover, it says A over B is equal to C over D, right? Which means that A times D equals B times C. Okay, A over B equals C. So we need to, it says to compare the magnitude of A plus D and B plus C. All right. So okay. A plus D and B plus C. Okay. So now let's do like this. Since A over B is given C over D, right? Now, what happens if I just subtract one from both sides? Okay. I mean, here we have A over B minus 1 equals C over D minus 1. The left-hand side, here we have, what does it bring? It's a common denominator. So here we have A minus B over B equals, here we have C minus D over D, right? So A minus B, it is positive. C minus D, it is positive. Okay, B times C. At the time, I can just write this, right? This C minus D, take to the left-hand side. So that will be A minus B over C minus D. I have just divided both sides by C minus D. And also at the same time, multiply both sides by B. So here we have B over D. Okay. So now from here, we know that B is greater than D, right? B is greater than D. So since here B is greater than D, because D is the smallest. So that means that B over D, well, it is greater than 1. So which means that, so B is greater than D, that means that B over D is greater than 1. Which implies that since B over D equals A minus B over C minus D, so that's equal to A minus B over C minus D is greater than 1. So now C minus D, we know that it is positive. So if you multiply both sides by C minus D, then A minus B is greater than C minus D. Now, if you take D to the left-hand side, B to the right-hand side, then we will have A plus D will be greater than B plus C. So that means that A plus, what is it? A plus B, D is greater than B plus C. Okay. All right, so that's it, Gabriel. Now we have some questions in exercise 2. Okay, so let's just do some of them. We don't have time to do all the questions. And after 10 minutes, I will finish the class. Question 1, arrange the following sets of numbers in ascending order. And here, I mean, questions are similar. The idea is similar. We can just do only one of them. Okay, so which one is it? For example, and for example, here, as here, all numbers are divided by 2009, right? Actually, it's equivalent to compare these numbers: minus 761, minus 513, minus 820, minus 104. And after, you can just write your answer. In the second one, actually, all numbers, actually numerators, are the same: 511, 511, 511. It's the same thing as comparing these numbers. It is minus 1 over 408, because we're just dividing all numbers by 511. So minus 1 over 386, and minus 1 over 890, minus 1 over 947. Okay, now here, let's just do only one question. Let's just do question D. Okay, for D, again, minus 7 over 8, 5 over 6, 8 over 9, 6 over 7. Actually, here, if you notice here, the difference between the numerator and denominator, it is 1, right? So first, let me just compare these numbers, okay? If I just compare, instead of these numbers, let me just compare these numbers for 7 over 8, and 5 over 6, and 8 over 9, and 6 over 7. Okay, so 7 over 8, I can just write it as 1 minus 1 over 8. 5 over 6, 1 minus 1 over 6. 8 over 9, 1 minus 1 over 9. And 6 over 7, 1 minus 1 over 7. Okay, so in general, as see here, if I can actually write the formula here, because this observation, if A is greater than B, then A over A plus 1 is always greater than B over B plus 1. Okay, so that's the same thing here. So because, as see here, this 7 over 8 is greater than 5 over 6, is greater than 8 over 9. Why? As see here, this 1, 1, 1, it's the same thing, right? So this 1 over 8 is less than 1 over 6. It is actually, this 1 over 9 is less than 1 over 8. 1 over 7 is less than 1 over 8. So among these numbers, then which one is the biggest one? Which one actually, we are actually removing the smallest amount from 1. That's 1 over 9, right? So that is 8 over 9 is the biggest one here. And the second one is 8. That is 7 over 8. The next one is 6 over 7. Next one is 5 over 6. Even if you cross multiply, for example, 36, 35, right? Or 64, 63. Now from here, if you multiply all of these numbers by -1, then we will get this thing. Minus 8 over 9 is less than minus 7 over 8, less than minus 6 over 7, less than minus 5 over 6. Okay, another example, arrange the following sets of numbers in descending order. Okay, so which one again? So we can just pick one question and do it here. 7, 14, 33, and 66, 21, 50, right? So the difference is 10. The second one is okay. This third one is 29. So we have nothing to do. So let's just do question D here. Solution. Question D. Okay. Again, all right, I can just ignore the negative sign. And after that, we can just interchange or change the inequality signs. Let me just compare these numbers. 7 over 17, and 14 over 33, and 29 over 66, and 21 over 50. Okay, 21 over 50. Okay. So now let me just compare these two numbers. Okay, first, if you multiply by 2, right, the second one, here we have 28 over 33. So it is 29 over, 30. It's not 33, 63. We multiply both numerator and denominator by 2, 66. So 29 is greater than 28, so we can just write this. I know that now 29 over 66 is greater than 14 over 33, right? So now if you compare, okay, these two numbers, how about these two numbers, 7 over 17 and the 14 over 33? Which one is greater? Actually, we have nothing to do, so I'm just going to multiply both sides by 33 times 17. So at the time on the left-hand side, we have 7 times 33 and 17 times 14. And 7 times 33 is equal to 210, 231. And 17 times 14, 170, and 68, 238. So this is greater. So that means that this 14 over 13 is greater than 7 over 17, right? So now even I can just write here like this. So 7 over 17 is less than this. Okay, that's also done. Now, how about the next one? Let me just compare the smallest one first. 17 over 17 with 21 over 50. Okay, because we have nothing to do here. Also here, 7 over 17 and 21 over 50. Okay. So if you just cross multiply 7 times 50, it is 350. 17 times 21, it is 340, and it's 354, 354. So it is greater. So this number is greater. So now, okay, we know that 7 over 17. Let me just write my final answer here. Okay, so this 7 over 17 is the smallest. All right. So now, how about if you compare this with 14 over 33? So this 14 over 33 and 21 over 50. Okay, before 14 and 21, actually they are divisible by 7. Okay, so actually I can just divide both sides by 7. Here we have 2 and cross multiply. Here we have 2 times 50, it is 2 times 50. And here we have 3 times 33, it is 3 times 33, 190. So this 14 over 33 is greater than 28 over 66. So actually 28 over 66 is the second smallest, because, and now I need to compare this 21 over 50 with 29 over 66. So if you compare these two things, 29 over 66 and the 21 over 50. So again, cross multiply 29, 30 times 50, 1,500 less than 150, that is 1450. 21 times 66, it is 1,200, 1,320. What is it? 21 times 66, 612, 612. It is 1386, 1386, 1386. So that's greater. So that means that this 29 over 66 is the greatest. So here we have less than 21 over 50, less than 29 over 66. Now from here, we can just write the final answer, right? Because they have minus sign. So we just write in red, dot, dot, dot. It says in descending order from the greatest to the smallest. So the greatest is, what is it? Minus 7 over 17. Greater than minus 28 over 66. Greater than minus 21 over 50. Greater than minus 29 over 66. Okay, let's solve one more question and then I will finish today's class. Refer to the following figure and find the value of c minus b plus a times e over d. So solution, we have already done the similar question, right? So c minus b plus a times e over d equals, so what is c minus b? Let me just write equal here, equals c is 1. So here we have 1 minus b is -3. So -3 plus a, -7 times e, that is 6 over d. What is d? It is 4. That's equal to minus minus is plus, 1 plus 3 is 4. Here we have minus because plus times minus is minus 7 times 6 is 42, 42 over 4, 42 over 4. And if you just simplify this, 4 minus 42 is divisible by 2, 4 is divisible by 2, that is 21 over 2. So that's equal to 2 times 4 is 8, 8 minus 21 over 2 minus 13 over 2. So the answer is minus 6.5. Gabriel, thank you very much for your patience and listening. And that much is actually, I hope you get some idea about how to solve these kind of problems and how should we understand. Okay, you have to practice other questions if you don't understand or if you cannot solve anything. Again, next week we have class, we can have some discussion. Okay, have a nice weekend. I will see you next week, Gabriel. Thank you. Bye-bye.